Video lesson 7.4, angle-angle similarity proofs. So just like congruency proofs, right, we can show that two triangles are similar, and we can do that formally in a formal proof. We can also do it informally in terms of a description. But important thing to note at the moment is, what does it mean to be that? So there are three different ways to prove that triangles are similar. Today's video is just going to show the first one, which is angle-angle similarity. So what does that mean? So that means that if two triangles have two pairs of corresponding angles that are congruent, and that's the key part, it needs to have two pairs and they must be congruent, then we can say that the triangles are similar by angle-angle similarity. And we can abbreviate that here by just saying AA similarity. It is important to note that if you are using the abbreviated version, you do have to put similarity, all right, so that it is clear and evident that you're talking about similar triangles, not congruent triangles, all right? And that's more important for the other two because they hold the same abbreviations as some of the ones that we're going to use for criteria. So it's important to make sure. Now, angle-angle similarity, I generally find that students and people don't have as much of a problem disassociating one with the congruency, because we don't have an angle-angle congruency. But it's one of those things that once we talk about it, it might start to spur your thought process is, oh, could I be that? And just the angles alone cannot show congruency, but they can show similarity. So let us do an example for number one. And I'm going to do this formally. Like I said, I could do this informally in like paragraph form as well. Again, if the question doesn't specifically state which one you have to do, again, either one would be fine. But typically, these types of questions are generally more formal, a little bit easier for like to kind of process the information formally, at least. All right, let's see. So this first one here states that we've got AC and BD intersecting at E, and that AB and DC are parallel. Prove that they are similar. So once again, we just want to make note, if you guys haven't paid attention before, that symbol means similar. So again, we're trying to prove that these triangles are similar to each other. So let's do a statement, reason, proof. Again, formally, we want to make sure that we have all the information organized. So again, labeling each statement with a number. So in this case, AC and BD intersect at E. That reason is given. And what does that do for me? So, well, if I have intersecting line segments, we know that vertical angles can be created. So I'm going to say this angle here and this angle here. Again, I can't call it angle E. It's too vague. So I'm either going to call it AEB for this first one and DEC for the second one, or I can just simply say angle 1 and angle 2. Again, labeling inside the diagram, specifying who angle 1 and angle 2 is in your particular proof. So now we can say that angle 1 is congruent to angle 2. And again, my reasoning for that is going to be vertical angles are congruent. All right, so we got our first pair of corresponding angles. Now we're going to work on the second one. And let's see, given that next given information, I'm told that AB is parallel to DC. My second given. So I look at the parallel parts and I say, well, if they're parallel, right, then all of those relationships out of parallel lines come in. So we've got these two being parallel. So I look at this and I see that I have that Z-like shape. So in this case, that Z-like shape here. And again, inside the crux of those two points would be pairs of congruent angles. So in this example, I've got angle A is congruent to angle C. And that is because parallel lines cut by a transversal form alternate interior angles that are congruent. Again, I'm abbreviating. I'm using the appropriate abbreviations and or symbols. If you don't like that, you can by all means write it out fully. That's fine. But again, as long as you use the appropriate abbreviations or symbols, you can do that in the proofs. All right, so in this case, again, all we're trying to prove is similar. I have here that this is one pair of angles and this is another pair of angles. So that is enough to make the claim that we have triangle ABE similar to triangle CDE. And my reason would be angle-angle similarity. And that's it. That's all you actually needed to do in order to prove that they are similar, right? Again, similar just means that they have properties that are all the angles are congruent and all the sides are proportional, right? So that's all was needed in this particular proof. A nice thing about similarity proofs, they are generally shorter, right? Because there's less information that we need to prove overall. And again, like I said, angle-angle similarity ones are generally speaking the easiest ones that we can work with. So let's look at another example. All right, so I look at this one here, and I say, okay, how can I prove that these two things are similar? So again, it could be formally or informally. Either version is fine. For this one, let's look at it and say, I think let's just kind of stick with the formality ones. I think it just makes a little bit more practice. Those are generally the ones that people have the hardest time doing it formally. So let's just kind of take a moment and continue practicing that here. So looking at these here, like again, don't get too worked up in the diagram. You might look at these and go, oh, they look like they're congruent to each other. Again, it's all about the wording in the question. Again, they have that symbol here for similarity. So I'm just trying to prove that they're similar, even though they do particularly look like they could be congruent to each other. But again, looks can be deceiving. We don't want to assume anything. We want to come up with a valid conclusion just for this part that they're asked to prove. So first one here is that ABC is an isosceles triangle with AC congruent to CB. So right away, I think, okay, here's my triangle here, ABC. It's telling me that AC and CB are congruent to each other. So think back to your isosceles triangles and the properties of those things, right? In that scenario, an isosceles triangle, if you have two equal sides, that also means that their opposite base angles are congruent. So we can make the claim that in this case, angle A is congruent to angle B. All right, and that would be because in an isosceles triangle, base angles are congruent. So there's my one pair of congruent angles. Next, I'm looking at this, and I'm also told that CD bisects AC. So let's look that up. CD bisects angle C. And that was given information. So a bisector, right? It's an angle bisector. It's dividing an angle into two equal pieces. So that's stating that this angle here and this angle here are equal. Again, I can name it ACD and BCD, or for speed and convenience here, I'm just going to label those angles 1 and angle 2. So we've got angle 1 is congruent to angle 2. And in this case, again, what is doing the dividing here. It's dividing an angle. So it's an angle bisector. So angle 1 and angle 2 are congruent because an angle bisector divides an angle into two congruent angles. Again, if that's all we're trying to prove is similarity, I've got my two pieces of information I need. I've got my similarity part. Again, you always want to make sure that you write down how it's written because the order that the letters are written matters. Again, the first one, so in this case, A has to match up with B, right? So these two, which we've proved. Angle C has to map to C, in this case, the two bisected ones, and then D along with D as well. Again, that order could sometimes change, so we want to make sure that the corresponding angles are matched up. So again, if they write it for you, you just want to be able to copy that down. Otherwise, you have to take it into consideration when you're writing it yourself. All right, and our last reason is angle-angle similarity. All right, let's do one more quick one here, just to give another example. So here we go. Statement, reason. Yeah, if you want, you feel free to pause the video, try this one out on your own, and then come back and replay the video to see if you did this one correctly or came up with the same information based on what you did. So feel free, take a moment, pause the video, try it out, and see what you got. All right, so let's take a moment. So hopefully you guys pause it on your own. So let's see how we can make this one work. So we've got triangle ABC. Again, the fact that it's triangle ABC is not necessarily anything, extravagantly important to write down. But again, I always say, if they wrote it down, it makes sense to put it in yourself. So I'm just going to copy that part down and say that triangle ABC. We have triangle ABC, and that's a given. And then we also have that DE is parallel to AB. All right, so what do we got? So the first thing is the parallel line part. I think that one's probably the first thing we'll look at. So if I have parallel lines, again, these are parallel. That means that all of those corresponding angles, the alternate interior angles, alternate exterior angles, all those properties that go along with those corresponding angles and such are true once we know that we have parallel lines cut by a transversal. So I do have transversals here. That would be the sides. So I look at this one, and we do have two pairs. I'm just going to pick one of them. And I'm going to look at this one, and I'm going to look at this one here. And I'm going to say that I have a pair of corresponding angles. Again, you may have used the ones over here on the other side. Again, doesn't matter which one you do. But I'm going to call that one angle 1 and angle 2. Even though I could have just called it angle A, but I already wrote it down, so we'll call it angle 1 and angle 2. So those are congruent because, in this case, we have parallel lines cut by a transversal form, instead of alternate interior angles like we had in the previous one, now we have corresponding angles that are congruent. All right. Now, no more given information, so this is where it might become a little bit more difficult. Now, you could do the same thing on the other side, right, with these angles here, right, and could say that those were congruent and ultimately for the same reason, and that you have parallel lines, right? This particular example allows that to be true. But we have another thing, and I'd like to point this one out so that it's a good one to see, and that is both triangles, they overlap here at C, right? So I've got this small triangle here, which I'm just going to highlight blue for a second, right? That's the small triangle, and then we've got the big triangle, which I'll highlight here in yellow, right? That's the two triangles that they're talking about. And again, you notice that they overlap at C, and C is exactly the same size in both of them. So we can make the claim here that angle C is congruent to angle C in both of them, aka it's congruent to itself, and that would be reflexive property. Right, so again, whenever you have something that is equal to itself, again, whether it's a segment or an angle, we're dealing with reflexive property. So either version could have worked there. I just wanted to show that part. So we've got those two pairs of angles now. So now there's enough to show angle ABC is similar to triangle DEC. And again, that is angle-angle similarity. All right, so hopefully you got a lot out of the video about how we can show that these things are similar. Take a moment here to go back over the video and you missed, or make sure you get all the notes and all the information down from doing so.